Hello friends, welcome to my channel Patra tutorial. In this video I shall be discussing about runtime stack mechanism. Okay, so this is very important concept to understand recursion as well as your merge sort and quick sort. Okay, so before discussing runtime stack mechanism, just let me tell you how your C program execute. Okay, so whenever you are writing one C program, like let me take one example here, hello.c. Okay, suppose I'm writing one program, that program name is hello.c. so after writing this program I am giving it to compiler, right? So I will pass this program to compiler here, compiler. Okay, by giving the command, what is the command you are giving? gcc hello.c, right? hello.c. so you are giving this command to pass this program. This is what normal English language code. Okay, and you're giving this program to the program file to the compiler, and it will generate what? It will generate what? It will generate one a.out file, right? a.out file. Okay, so after giving this hello.c file to compiler, compiler will generate one a.out file. This is nothing but what? Your executable file or machine instruction. Okay, then again you are giving this a.out file to your, or you are loading this a.out file and executing this program, right? By giving the command what? ./a.out. Okay, so this command will load your machine instruction or executable code into your memory, and it will give the output. It will execute and it will produce the output. Okay, so this is the process of executing a C program, right? So first you need to write the program hello.c, save it, then pass this file to the compiler by giving the command gcc space hello.c, and then the compiler will generate one a.out file. That means it will convert this high level language program to low level language or machine understandable language. Okay, then again you are passing this file will be there in your secondary memory only, in hard disk. Okay, so to load this file into the main memory and execute it, you need to give the command ./a.out. okay, then it will produce the output. So this is the basics way of executing your C program. Okay, so whenever you give this command ./a.out, this file will be loaded into your computer memory, right? That is main memory or RAM. Okay, random access memory. So whenever you load this program into the main memory, it will create one structure in your memory. Okay, for this particular program. Okay, so let me show this diagram. Okay, so this is the structure that will be created once you give this command to the compiler, and this type of structure will be created for your program, that is hello.c. Okay, so this is the memory layout of C program. Once you load one C program into memory, so this kind of structure will be created. Okay, so this total structure is divided into several parts. Okay, so first one is text or code segment. So this part of memory, this is nothing but this is there in the main memory, right? And these are the different parts that memory is divided into. So this code or the text segment will be holding the executable file, that is a.out file. Okay, so this code will be stored here in this part of the memory. Okay, then initialized data segment, what it will do is, suppose there is an instruction in program like int x equal to 10. Okay, so what is the meaning of this? You are declaring one variable x, and at the same time you are initializing the value of that variable to 10, right? So declaration as well as initialization. So if the variable is initialized in the program, that variable will be stored in initialized data area. Okay, so x will be stored here. Okay, so all the initialized variable will be stored in your initialized data segment area of the memory. Okay, and what is uninitialized data segment? Suppose there is a variable I am writing like int k. Okay, that's it. I am just declaring but not initializing the value. So in that case, this type of uninitialized variable will be stored in uninitialized data segment of the memory. Okay, and next is what? Heap. What is heap? all the memory allocated using dynamic memory allocation. Okay, dynamic memory allocation by using what? Malloc function, calloc function, realloc function. Okay, so whenever you are using that malloc function, calloc or realloc function, that is dynamic memory allocation, the memory will be allocated from the heap area. Okay, remember this one. And the last one is what? Stack. What is stack? Stack, whenever there is a function call in your C program, one runtime stack will be created in the stack area. Okay, and what is the job of that stack is, I will discuss that runtime. What is runtime stack mechanism? Okay, so these are the basics things. Whenever you load a C program into your memory, so this kind of structure will be created. Okay, and the total memory area of that structure is divided into different parts, code or text section which will be holding the executable file, and this area is generally read only. Okay, so the text segment is consisting of the machine instruction, okay, that the CPU executes. Okay, and this text segment is often read only, because to prevent a program from accidentally modifying its instruction. Okay, so it will prevent the modification of that instruction, whatever they are in a.out file. Okay, and this will hold the initialized data, this will hold the uninitialized variable, and heap area, all the memory allocated using dynamic memory allocation technique will be allocated from heap area, and stack area I will discuss broadly in a few days. Okay, so now one more point, important point here to be noted is that heap is growing. What is the meaning of this arrow? Heap is growing from up to bottom to up, and stack is growing from top to bottom. Okay, so actually these memories are allocating during the runtime, right? So we don't know the exact size of memory, means how much memory will be allocated dynamically from the heap area, and I don't know how much memory will be allocated from the stack area. So that's why stack is growing from top to bottom, and the heap is growing from bottom to top. Okay, so I'll discuss this part only to make you understand what is runtime stack mechanism. So just let me erase all those things. Okay, so this is the memory structure will be created once you load the C program. Right now, a few points to remember is that when there is a function call, a runtime stack will be created in the stack area, this area. Okay, at runtime when the program is executing. Okay, now second point is that after every function call, the remaining lines of codes will be pushed into the stack. Okay, so I have written here the remaining lines of code will be pushed into the stack, but exactly it will not store the lines of codes, it will store the next address. Okay, that means suppose there is a suppose here is one main function. Okay, and there are some instructions are there, and here is one function called a. Okay, there is one function call, then again some instructions are there. Okay, so whenever there is a function call, it will go to that function a, right? Wherever it is defined, it will execute this function, then again it will return back to this instruction, right? So it will store the address of this instruction in a stack. Okay, so this is runtime stack, and memory for this stack will be allocated from this stack area. Okay, so whenever there is a function call, a runtime stack will be created, this stack will be created, and after every function call, the remaining lines of code, this one, it will not store exactly the lines of codes, but it will store the address of the next instruction to be executed and some other information. Okay, so suppose this is 100, then 100 will be stored here. Okay, just to remember, so that after completing this function, it will return back to this address. Okay, it will not go to this or that one. Okay, and the third point is that each entry in the stack is called activation record. So these entries are called activation record or stack frame. Okay, there may be some other entries also here. If there is a function, recursion function is there, so it will call again and again, right? So each time it will call the function, then the address of the next instruction will be stored in the runtime stack. Okay, so these entries are called activation records or stack frame. Okay, so let me take one example so that it will be more clear for you. Okay, so this is one program I have taken. uh, always the program execution start from main function, right? Because the compiler calls the main function. Okay, so in this program will start from here. Okay, so it will execute this line, and always the programs execute sequentially, right? That means one by one, line by line. Okay, so it will execute this line. This is nothing but declaration and initialization. Then there is a function call. Okay, see, add x and y. So I am calling one function here. So control will go to from this line to this function, right? So one runtime stack will be created now here. Okay, suppose this is my runtime stack. Okay, and what it will do, it will store the address of next instruction. Suppose this is 100, I'm writing here 100, the address of this instruction is 100, then 100 will be stored here. Okay, and it will control will go to this line, then it will execute this function, right? So again there is one variable sum, declaration of variable sum, then sum equal to a plus b. So 10 and 15 will be coming here, right? So 10 will be coming here and 5 will be coming here. Then sum equal to what? 15. Then it will print addition equal to 15, right? So it will print addition equal to 15. It will print this line. Okay, this one. Then it will reach here. Then it will return back to what? Now it will look at the stack. What is the next instruction to be executed? And it will pop out this one. Okay, and it will go to this point. Then it will execute this one. Again it will print addition performed. Okay, so it will print addition performed. Then again there is a function call. Again I am calling the sub function by passing x and y as a parameter. So now it will go to this function, right? This one. But before going to this function, it will store the address of next instruction in the runtime stack. Remember, this one already popped out and already executed. So now suppose the address of this instruction is 200. Okay, so 200 will be pushed into the stack, and then it will go to the next that function, the function which it is calling. Okay, then again it will execute this function, something is there, then it will print this one, subtraction equal to 5. Then after reaching this point, again it will go to the stack. That means it will find out what is the address of the next instruction to be executed, and since it is 200, it will control will come to this line again, then it will execute this one. Okay, then it will print subtraction performed, then it will reach the close curly bracket and it will complete the program execution. Okay, so this is how the runtime stack is useful. Okay, let me take one more example so that it will be more clear. This is very simpler one. Okay, so just look at this program now. Okay, so this is the main function, and there are two variables, x and y, x equal to 10, y equal to 5, and I am calling one function add. Okay, by passing x and y as a parameter. So before going to that function, it will store the address of next instruction, right, in the runtime stack. Okay, and the memory for this stack is allocated from the stack area. Remember that one. Okay, so suppose the address of this line is 100. I'm writing. Okay, so 100 will be stored here. Okay, 100 will be stored here, and then it will go to that add function. Okay, this is nothing but this one. Okay, then inside that add function, see, it will store means what? It will just remember that after completing this task, I have to return back to this line. Okay, so it will store the address of next instruction in the stack, and it will go to that function. Okay, but here in this function again I am doing some task, right? Something I am doing. So what is the first task I have to do here is I am declaring one variable here, int sum. Okay, so and then sum equal to a plus b. So a equal to 10 and b equal to 5, right? So a equal to 10, b equal to 5. So it will give what? 15. Then see, after getting the addition of two number from this function, again I am calling another function called square. Okay, so whenever there is a function call, the next the address of the next instruction will be pushed into the stack, right? So before going to this function, it will store the address of this instruction. Suppose this is 200 here, then 200 will be pushed into the stack. See, now there are two different entries in the stack. So these are called activation record or stack frame. Okay, so it will store the address of next instruction, then it will go to the square function. Okay, that means control will go to this square function. And what is the parameter? Sum, right? Sum was what? 15. So 15 will be coming here, and these are local variables, so nothing will happen. And inside that square function, what it is doing, again it is declaring one variable called sq, and sq is nothing but it is holding means storing the square of a, that is 15, right? So square of 15 is what? 45. So sq will be what? 45, right? Then it will print square equal to %d, that is sq. So it will print now 45 here. Output, it will give square equal to 45, and it will reach this line, right? That means the execution of this program is completed. Then once it will reach here, no, it will go back to what? Stack. Okay, then what is the next instruction to be executed? And the top of the stack is what? 200. Then it will directly go to the address 200 here. Okay, this one. Then now it will execute this line, and it will print what? Addition equal to 15, that is nothing but sum. Okay, so it will print addition equal to 15. Okay, then after executing this line, it will go to the next line, sequential execution. Then again it will print addition performed. Okay, now it will print addition performed. Then it will reach this line, right? Once it will reach this closed curly bracket, then again it will go back to the stack. This part is already completed, right? It will popped out. Then next is what? 100. Then again from the stack it will come to know that I have to execute the instruction number 100, or the address of the instruction 100. So again it will go to this 100 line, this one. Okay, then again it will execute this line, and it will print what? Program execution completed. It will print program execution completed. Then it will reach this line, and the program will be terminated. Okay, so this is how your runtime stack is working. Okay, that means whenever there is a function call, the address of the next instruction as well as some other information will be stored in your runtime stack. Okay, and once the runtime stack is empty, that means what? All the instructions are completed, and it will reach the close curly braces of the main function. Then program will terminate. Okay, so I'll use this concept in the next video, that is what? Merge sort and quick sort. So and okay, so it will be more clear in that video. I'll take one example. So that's it for today. Thanks for watching, and if you like my video, give your feedback by commenting on this, and don't forget to subscribe my channel. Thank you guys.